Module 6, problem number 9. The accompanying data represent the number of days absent X and the final exam score Y for a sample of college students in a general education course at a large state university. Complete parts A through E below. So I just want to point out first that we have X, as that's our predictor variable. So we would be using days absent to predict the final exam score, which is Y, our response variable. So remember, the predictor is the input, the response is the output. So we have our data set here. We're going to wait until we read part A to go through that. Part A, find the least squares regression line treating number of absences as explanatory variable or predictor and the final exam score as a response variable. So we're going to go and click on our data set. As you see here, we have the number of absences X is 0 through 9, and then the final exam score is Y, and it ranges from about 89.4 to 66.4. Now I'm just going to point out something. See how our X is increasing from 0 to 9, and then our final exam score is decreasing. That's what we would expect. We would expect that the more absences you have, the worse you would do on the final exam. It's not always the case, but it is the expected. So that's going to tell us already that we're thinking that we're going to have a negative correlation. So let's go ahead and open this up in StatCrunch. A lot of times it helps just to think about this stuff intuitively before you start going too deep into the problem, so you know what results to expect. So now that we have StatCrunch here, let's go to Stat, Regression, Simple Linear, and we're going to just simply select our X. It's very nice that they put X and Y there. X and Y variables, and we're going to click Compute. That gives us our results here. We have what we're looking at right now. We have, this is the equation, but if you want to look at it a little bit easier, here's our, so we have our slope and intercept right here, which is what we're looking for in the problem. So let's go ahead and put in our answers, round to 3 decimal places. So our slope, remember your slope is what you multiply by X. That's negative 2.775. And then our intercept is 88.818. Let's check our answer. Well done. Part B, interpret the slope and the y-intercept if appropriate. Choose the correct answer below and fill in any answer boxes in your choice. Now, the one thing I want to talk to you about, the one time your intercept is really not going to be appropriate to interpret is if 0 for the intercept is not a possible value or is not in the range. So that means your intercept is what your y value was when X is equal to 0. So if X equals 0 is not a possible value, it's not going to be appropriate. Let's say, for example, you're looking at the weight of a person as your X variable. Your weight is never going to be 0. So it's not appropriate to interpret your intercept at that point. In this case, the number of absences, 0 is very possible. So it is appropriate to interpret that. So we know the one right here where it says it is not appropriate to interpret the slope. We already know we're not looking at that. And, or excuse me, yeah, I'm sorry, not the slope, the intercept here in part C. I'm sorry, excuse me for that. So this is not appropriate to interpret the y-intercept. We already know that C is not going to be the answer. In this case, also the slope is perfectly fine to interpret because it tells us how much of an impact those absences have. So we know that we're going to be interpreting both. That's part A. So for every additional absence, a student's final exam score drops, and we're looking right above it for the answer. That's our slope right there. So it says drop. So you don't need to include your negative. It's telling you it's going to drop 2.775 points. So 2.775 on average. That's not guaranteed. That's just an estimated average for your predictions. The average final exam score of students who misses no classes is, and that's going to be your intercept. In this case, it's 88.818. So let's check our answer. Excellent. All right, part C, predict the final exam score for a student who misses 5 class periods. So to find that, we just need to simply plug in 5 for our X and see what the output is. So let's go over here. So here's our equation from above. We have y hat equals negative 2.775 times X plus 88.818. So right here, all you see is I plugged in that 5 for X, and after I type it into the calculator, I get 74.943. Now let's bring that over here. And it says here to round to 2 decimal places. So we have 74.94. This work. All right, so compute the residual. Remember, the residual is the actual value from your data set minus the predicted value. So let's go to our data set. And so for 5, our actual value is 73.7. So let's come over here. Let's say we're going to look at residual equals actual minus predicted. So in this case, it's going to be 73.7 subtract 74.943. So once we plug that in, we get negative 1.24. So let's plug the negative 1.24. Check answer. Excellent. Now this is important that you make sure you get the actual minus predicted and not the other way around, because you'll end up with a negative or a positive in the wrong direction. You'll get the same number no matter which way you subtract, but you want to make sure that you have that actual minus the predicted. All right, is the final exam score above or below average for this number of absences? Well, let's look back at our residual. If the residual is positive, that means that the actual is above. If the residual is negative, that tells us that the average is below. And that makes sense. It's just looking at it, you can tell that, but that's how that negative comes into play. So since our residual here is negative, we know that it's below. All right, continue. All right, draw the least squares regression line on the scatter diagram of the data. Now, I will point out a couple things. One, you can tell right away this is not it. Remember, your least squares regression line is going to go through as close to all the data points as possible. This literally just goes through one point, almost an arbitrary line. So we know that's not it. Also, your least squares regression line is going to be a straight line. It will not. This is more like what we would call logistic regression, which is outside the scope of this class and not something that it would look like in that case. But you're only going to be looking at a straight line. This clearly has some bumps, not a straight line. This one, this line is literally y hat equals 80. Just a straight line, and it's still kind of close to our data points, but it doesn't look nearly as close as this one. Now, if you go back to your linear regression results from StatCrunch and you click over the right arrow, you'll see your line right here. And this kind of gives you an idea of what you're looking at here. Clearly, we're not looking at a straight line at 80. Clearly, we're not looking at a bumpy line. So we can tell already that our answer is A. All right, continue. Would it be reasonable to use the least squares regression line to predict the final exam score for a student who has missed 15 class periods? Why or why not? Well, let's go look at our data set. 15 is nowhere near the development data set. Our development data set goes from 0 to 9. 15 would be way over here, and it was not, so therefore it really would not be appropriate. Now, I will tell you, kind of in the real world, there's some stuff you can do, or stuff you might do, where you might still use a data set or use a model to make a prediction on a data set or a value that's outside of your range. That's not typical. You would do a lot of validating, and that's a whole other thing, but that is possible in the real world. It's not ideal, and it's not something you would want to do. That's kind of a side note, but for this case, for sure, since it's so far outside of our data set, we would say no, because the 15 absences is outside the scope of the model. All right, that's how you do number 9. If anyone has any questions, let me know.